Go ahead and try the warm-up, pause the video, and then unpause it when you're ready. So a quadratic equation is something in the form ax squared plus bx plus c equals 0. It must have degree 2 in order to be quadratic. It must be in one variable. And all exponents must be positive integers. At first you might say that x minus square root of x equals 2 is not a quadratic equation, and that's okay. We would call this a radical equation. So I don't have a ton of space, but I'm going to solve that equation over here. So x minus the square root of x equals 2. I'm going to subtract 2 to this side, and then I want to add that square root of x to the other side. So that gives me x minus 2 equals the square root of x. I'll square both sides. Remember that when you're squaring this, you need to write it twice and double distribute so that you get x squared minus 4x plus 4 is equal to x. Subtract x, that we get x squared minus 5x plus 4 is equal to x, and then we will factor. So that factors into x minus 4, x minus 1, x minus 4 equals 0, x minus 1 equals 0, x equals 4, x equals 1. And since this is a radical equation with a restricted domain, I do have to check. So I'll go back up here to check. So when I check 4, that would be 4 minus the square root of 4 equals 2. So that's 4 minus 2 equals 2. 2 equals 2, that works. Now let's check 1s. That would be 1 minus the square root of 1 equals 2. 1 minus 1 equals 2. 0 does not equal 2, so x equals 1 is extraneous. So we can write an equation in quadratic form like the one that we just did if we can write it as a times some quantity squared plus b times some quantity plus c equals 0. So if I wanted to write this equation in quadratic form, what I would do is first I would get it equal to 0 like we have been doing. And then I would say, okay, my quantity that's being squared, or even easier, that quantity that's in the middle is the square root of x. And I'm looking to make sure, is this first thing, the middle thing, squared? And it is. So then I'm going to use, you can either use star or a u. Let's use a u at first. So I'm going to let u be the square root of x. So that means that this first term is the square root of x squared. This next term is 1 times the square root of x minus 2 equals 0. So this is another way to solve this problem. And let's try this here on number 3. You can either use a U or a star. A star can be more fun. So since I started with U in this problem, we use U here. So let's see. Again, I want to start out by setting it equal to 0. And I want to let U be the square root of x. So again, I'm going to say, okay, that first term is the square root of x squared. That next term is 1 times the square root of x minus 2 equals 0. And so now I can replace these square root of x's with u. So I can say this is u squared minus u minus 2 equals 0. Well, I know how to solve something that looks like this. I factor it. I look for two numbers that multiply to -2, add to -1, so that would be -2 and +1. I get u minus 2 equals 0, u plus 1 equals 0, u equals 2, and u equals -1. Well, I'm not done because the problem is asking me about x, not about u, so I do have to go back and substitute this back in. So I'm going to take what I had for u, and I'm going to replace 2 as u, so 2 equals the square root of x, and -1 equals the square root of x. In order to get x out of that square root, I would need to square both sides. So then that would give me 4 equals x, and 1 equals x. Notice that these are the same two answers that we got from above. Since going back to my original equation, it has an x under a radical, which means its domain is restricted, I need to check these answers. So I'm going to check 4 and 1 to see if they work. So 4 minus the square root of 4 equals 2. So that's 4 minus 2 equals 2. And that one works. And now let's check 1. 1 minus the square root of 1 equals 2. 1 minus 1 is 0, which does not equal 2. So that one does not work. 4 is our only answer. Let's try 5 and 6 in these notes. We'll do number 4 in class together. So the first thing that I want to be able to do is I want to be able to think about this equation, number 5, as something being squared plus that something plus a constant. And usually if I can look at the middle term, that helps me to think about what that something has to be. So I can rewrite number 5 as 1 divided by x squared, 2 times 1 divided by x squared, minus 1 divided by x minus 3. And so now I can clearly see that I can let my substitution, u, be 1 divided by x. So now I can rewrite this as 2u squared minus u minus 3 equals 0. Now I have a quadratic equation that I can solve by factoring. And so let's see, I'm going to multiply the first and the last to get -6. I need two numbers that multiply to -6 and add up to -1. -3 and +2 work. So that's 2u squared minus 3u plus 2u minus 3. We'll group the first two terms and take out a GCF, that would be u. In the next two terms, the GCF is 1. And now the GCF of that whole statement is 2u minus 3. And you're left with u plus 1. We'll set each of these equal to 0. So I get u equals 3/2 and u equals -1. Well, remember that this problem isn't asking you what u is, it's asking you what x is. So you do have to go back to what you originally let u be. You let u equal 1 divided by x. So that means that I'm going to replace u with 1 divided by x and 1 divided by x. And in order to solve something that looks like this, let's see, let me write this as 3 divided by 2. I can cross multiply here. So I can say that that's 2 equals 3x, which would give me 2/3 equals x. Over here, I could multiply by x on both sides. So that would give us 1 equals -x, or x equals -1. Go back to your original problem. Since this was a fractional equation, the x is in the denominator, we do have to make sure that neither of these values make our denominator equal to 0, and they don't, so then we are good with both of these. Alright, let's look down here at number 6. So this says 6x squared plus 2x to the 4th minus 8 equals 0. The first thing that I want to do on this problem is get it into standard form. I want to write it in descending order. 2x to the 4th plus 6x squared minus 8 equals 0. The next thing I notice is that all three of these terms have a common factor of 2. And since I'm solving this equation, that means I can go ahead and get rid of it. So that would give me x to the 4th plus 3x squared minus 4 equals 0. If I want to use u substitution, that means I need to be able to think about the first term as something being squared plus that same something minus 4. Well, since the middle term is x squared, let's see if I can rewrite x to the 4th as x squared. Since x squared squared is the same thing as x to the 4th, this works. So then I can rewrite this as 3 times x squared minus 4 is equal to 0. So what I'm seeing here is that I need to let u be equal to x squared, so that I can rewrite this as u squared plus 3u minus 4 equals 0. I want to try and factor this. Since the leading coefficient is 1, I should be able to go ahead and factor this quickly, looking for two numbers that multiply to negative 4 and add to 3. That would be positive 4 and negative 1. So then that would give us u plus 4 equals 0, u minus 1 equals 0. So that's u equals negative 4 and u equals positive 1. Well, remember the problem is looking for x, not u. So I do have to go back to what I originally let u be. And I'm going to replace this, so x squared equals negative 4 and x squared equals 1. To solve something that looks like this, I take the square root on both sides. And then I get x equals plus or minus. Remember, you put a square root into a problem, so you have to take the square root. The square root of negative 4 is 2i. And the square root of 1 is plus or minus 1. So I have four answers here: positive 2i, negative 2i, positive 1, and negative 1.